Last July, nearly 1 year ago, when I was training the REU students on the operation of the 82-inch telescope, the lower curtain ran away. The only way we could stop it was by cutting power to the dome slip rings by hitting the e-stop button. Since that time, there have been several runaways of the lower curtain. The most recent event, 2 weeks ago, resulted in the lower curtain and the upper curtain refusing to move at all. A similar problem has been developing over the years with the dome shutter. Especially during cold weather, the dome shutter may take up to 5 minutes to open. This has been billed as cold delay, but it's really a different kind of delay. Before going on, let's trace the signal path when you press one of the buttons to control the curtains or the dome slit. So the heart of the console is this touchscreen computer, which was programmed by Mark Blackley. And the main function of this touchscreen computer is to record the state of all these switches and then transmit these data on single-ended RS-232 into a device called the Programmable Telescope Interface in the control room. So that signal comes out the back here, goes under the platform, up this fire hose, which accommodates the platform when it rises, then down this conduit, under the dome floor, and into the control room. So let's go into the control room and take a look at this programmable telescope interface. Now we're in the control room, and that serial line from the console ends up at this device called the Programmable Telescope Interface. And this box has two jobs. First, it decodes the serial data and breaks it back out into 24-volt control signals. It also has an LED panel that can tell you which of the signals are active. So this bundle of cables then runs under the floor and into the ante-room, where you can see some of the dome drive equipment through these conduits and through the hole in this wall, which will take us into the old control room on the northeast side of the North Pier. Let's take a look. Now we're in the old control room, and those cables come through this hole in the wall. Some of them end up in this area. Some go through this conduit to the Osiris cabinet. Let's go over there. So the curtains and the dome slit go to a solid state relay board, also built and programmed by Mark. And some of those signals then go into the motion controller and then out to various systems. And in this case, the curtains and the dome slit then loop back their 24-volt control signals to this box. Actually, it's not a box, it's just a plate. And this has a basic stamp programmed by Mark. And it takes these 24-volt control signals coming in here and turns them back into serial. That serial data is then sent to a MOXA serial to RF converter on top of the North Pier. You can just see the antenna right there. So this signal is then transmitted to the MOXA RF to serial converter up on top of the stairs. And way up there, we can just see the receiver. That serial line is then routed down the stairs, and it goes into a number of control panels which break it back out into 24-volt signals and ultimately ends up here in the contactor relay box. And this is where some of the mischief is happening. But the point is that this is just a chain of failure. It's impossible to say where the signal is dying in this chain. And it was all programmed by Mark with basic stamps, like 25-year-old, 30-year-old technology. Nobody knows how it works. It's not repairable. Let's take a closer look at that relay control panel and also review the signal path from the console to these relays. So you have to go under the bridge. This is a rather dangerous place to be. You would never send an observer under here to press a reset button. So here's the control panel. All these relays for the upper and lower curtain and for the dome slit. So let's quickly review how these 24-volt control signals get here to actuate these 208-volt three-phase relays. So you start at the console with the touchscreen, which records all of the button states on the console and packages them up into a simple serial RS-232 single-ended protocol, sends it under the platform, out that fire hose, under the floor, into the control room, where the PTI breaks that serial packet back into separate 24-volt control signals. Those then run behind the north pier and they come out in the old control room. There they go to the Osiris cabinet where there's a bank of solid-state relays, and then some of those 24-volt control signals then go back to the unit by the old dysfunctional telephone that we looked at, and those are turned back into serial. Those serial commands then go up to this MOXA serial to RF converter, and that transmits through Wi-Fi the serial data to the matching MOXA unit on the stairs, which we can't quite see from here. And that serial data then goes back down the stairs and over to some electronics in here where it's converted back into 24-volt control signals. There are a couple of things I don't like about this control panel. The first is that the relays are not properly sized for the motor loads. These are 1.5 horsepower relays for 2 horsepower motors. So technically that's incorrect. Very little is labeled here. Helpfully it says lower curtain, upper curtain, and shutter, up and down, but it's not really clear what's going on here. There is a wiring diagram of sorts in this box. It's not really as much of a diagram as is just a list of inputs and outputs and names, but nothing's labeled over here, so good luck trying to figure out what's going on. And this, again, is not a place where you would ever send an observer to press a reset button or to check on anything. All of these three-phase contactors are extremely dangerous. Another thing that's not quite right about this setup, besides the incorrectly sized relays, is that they're all on the same circuit breaker: upper curtain, lower curtain, and dome shutter. And there's no overcurrent protection, no dropped phase protection, no protection at all except for the dome shutter, which has this current monitor. And a good thing, because when you open the dome shutter, the inductive load is so high that the dome lights dim. To recap, last year the lower curtain started to fail with runaways. Today, both curtains are inoperable. For several years, the dome shutter has been failing to open. Just wait till it fails to close with bad weather coming. This is a really good time just to throw out the junk and to get rid of that chain of failure that I showed you and replace it all with off-the-shelf parts and a direct line of communication using Track 82, which is already in the control loop and controls the dome shutter and incidentally the mirror cover and baffle tube. I'm going to show you a plan where all this can be done for about $2,000, and reasonably I can be done in a few months. All this work can be done safely on the electronics bench without energizing with 208-volt three-phase power. That's where I'm going to need help from a qualified electrician like Shane Hank, who can help engineer and install this final part of the project. So let's get this done.